Okay, here's our first example. It says, what is the wavelength of red light? I'm going to underline a red light. If the light has a frequency of 4.3 times 10 to the 14th hertz. That's a little hard to see, but that says 4.3 times 10 to the 14th hertz. So the first thing you got to do is figure out what you know. Right off the bat, you know that the speed of light is 3 times 10 to the 8th meters per second. That's a given. You also know that the frequency right here is 4.3 times 10 to the 14th. So that's what you know. And the wavelength, which I'm going to circle and label up here, lambda, is what you're looking for. Okay, so this becomes a pretty simple problem. If the speed of light is frequency times wavelength and you want to find wavelength, you just got to divide both sides by f. So the wavelength is going to be the speed of light, which is 3 e to the 8th, and I'm going to put parentheses around that, divided by 4.3 e to the 14th, and I'm going to put parentheses around that. Okay, so I typed my answer in right here, and I rounded this to 6.98 e to the negative 7th meters. That's a super tiny number. What I've done below is just rewritten it. Because light has such small wavelengths, it's common to write it in terms of something called a nanometer. So if you move this dot over 2 times to the right, that makes this number 2 times smaller because you'd have to go 2 extra steps to get back to where it was. The reason I'm doing it like this is because 10 to the negative 9th meter, that is called a nanometer. So this right here is how you will most commonly see that written. So the wavelength here is 698 nanometers, and that is very, very well within the red light frequency range. All right, here's the next question. It says, what is the frequency of blue light if the light has a wavelength of 480 nanometers? So blue light, I'm going to underline that. I'm going to underline this right here, and that's wavelength. And I'm going to circle this because that's what they're trying to get us to find, and that's the frequency. So again, we know that the speed of light is 3 times 10 to the 8th meters per second. I'm just writing it 3 e to the 8th. In this case, we don't know the frequency, but we know the wavelength is 480 nanometers. What that means, because nanometers have the decimal right here, if I go like this, 2 times to the left, you could write it like this. Or you could just keep it in nanometers, and then 480 nanometers means it's just e to the negative 9th meters. So like that. Either one of those is fine. I would do it like this, 480 e negative 9 for nanometers. And we're looking for frequency. So if you start out like this, and you're looking for frequency, you got to divide by wavelength on both sides. That cancels off, so frequency equals speed of light divided by wavelength, like so. So when you put your numbers in, it's going to look like this. Frequency equals 3 e to the 8th divided by 480 nanometers, which we're just going to say e to the negative 9th. Notice I put parentheses around it again. So there's our answer. Now, when you're typing this in on Moodle, the easiest way to do it is just write 6.25 E14. Typing times 10 caret 14 doesn't work as well on Moodle, so just do this one right here. There's your frequency. All right, this last example is just a regular distance, speed, and time question. So it says, according to scientists, it takes light from the sun 8 minutes and 20 seconds to reach Earth. How far does the light travel going from the sun to the Earth? In other words, how far away is the sun? So this is really all they give you. But you know the speed of light is 3 times 10 to the 8th meters per second. The time, 8 minutes 20 seconds. Now, 8 minutes times 60, because there's 60 seconds in a minute, gives you 480 seconds, plus that extra 20, and you get 500 seconds, okay? And you don't know the distance. So if speed equals distance divided by time, you just got to go and multiply both sides of the equation by t. That cancels out. So distance equals the speed of light times the time it takes to travel. So in this case, here's how you would type it in. 3e to the 8th times 500 seconds. We're going to see what we get. All right, so when you write your answer down, this is what the real number is. It's 1, 5, and then 10 zeros. The reason we like scientific notation is so you don't have to write all that. So if you put the dot in the ones place, it'd be 1.5, and then you got to count over 11 times to move the decimal where it needs to be. So the way you could type that in on Moodle is 1.5 E11, 1.5 times 10 to the 11th meters. That's how far away the sun is. That's pretty far.